Okay, now we're up and running. First agenda point, we can look over the full agenda after this one, but we will get right into it. And Philip will guide us through the results of the survey we sent out before this workshop. And yeah, take it away, Philip.
Okay, can you see my screen?
Yes, it's not in full screen yet,
I can put it full screen, but
if it helps.
Is it in full screen now? Hello?
No, yes, it's your presentation mode now, so it's full screen, but it's your view.
So there's if you go to the menu at the top, Philip, second menu, there's a selection. I think you switched back now.
Yeah, I switched back.
Yeah, but if you stayed on the previous one and went to on the speaker notes, there's a little menu saying switch speaker and display view, something like that, at the top.
Oh, that one.
There's one of those top menus there, and if you click on it, there's something like switch. We still have people coming in, so it's not a problem. Okay. Try the left-hand menu, the one at the left. Is there not a selection saying switch speaker and?
Yeah, there is switch.
Okay, let's try that. Yeah.
Yeah.
Let's see.
So do you see my big screen?
No, it's still the presentation mode that you're supposed to see. Try the second menu item on that one. I wish I speak French at this point.
No, that's fine.
Oh, no. You had it.
I did nothing.
Oh, crap.
Maybe it was just a delay. Maybe you did actually get it the first time. I think the update is a little slow. Try the switch again.
Okay.
There it is.
No, it's there. Don't touch. Never touch it.
I need
All
to.
Right. Now we're up and running.
Okay, before we go with the usual conference issues. Okay, but that's fine. This is the double live, guys. Yeah, before I present the result of the survey, we would like to have a couple of volunteers taking notes in the background. I will take notes on my side later, but if a couple of you guys can volunteer to record their notes, very raw notes, okay, whatever is convenient for you, that would be very helpful. Okay, so I hope there will be a couple of volunteers. You can either say it or put it in the chat. Okay, so survey result. So after the virtual member meeting of May, we sent out a survey to ask for the community expectation concerning CVII, and I will show some of the results we get from this survey. So there were two aspects, one on the project technical scope, another set of questions was on their commitment or engagement of participants into the work. So let's start with the technical scope. So there was about 30 participants that answered, including 6 OEMs, and we expect that when we launch another survey, very likely after this meeting and to prepare for the next virtual event or physical event, we expect to have more answers from you guys. Anyway, there were some very interesting results in this survey. One, I just selected some of the questions that were asked because they seem to me the most significant. And there was series of questions where we ask the people to indicate the degree to which they agree or disagree with some statements. Okay, and here is a couple of statements on the standardization, and I summarize this as what is key to ease in-vehicle integration. So the first item is standardization of data and APIs. Actual definitions is necessary for in-vehicle integration. So this is what we are doing, okay? And so most people say somewhat agree or strongly agree, okay? So it means that for the people who answer, we are doing the right thing, okay, with respect to the easing of in-vehicle integration. And if someone disagree with this, this is the right time to say it, okay? Gunnar, can you send the link to Mark, please, in the background? I just got a text from
I will do it.
Thank you. The second question was standardization and collaborative development of data exchange and integration technology. This is about the work we are doing in CVII tech stack. Is necessary for in-vehicle integration inside or between ECUs. And similar question, so there were the people said we are doing the right thing, okay? Then the next question was relevant to the easing of vehicle edge implementation, okay? This is the famous buzzword we are all using now, okay? And these the topic were standardization and collaborative development of data protocols and integration technologies necessary for the vehicle edge. So there was a very strong support for this, okay, saying that we are doing the right thing. And standardization of data and APIs, actual definition, is necessary for the vehicle edge. So same question. So people think that it's very important to work on the vehicle edge, how to ease the implementation of the vehicle edge, and of course how to ease the integration of these software stack and in the vehicle and to the cloud. Then there was an interesting question about do you agree or disagree that standardization of data and APIs is necessary for the third-party web cloud application development? Okay, so we are all feeling the push or the pull from third-party application developers to create applications, okay, and the question standardization of data and APIs key to ease third-party web cloud application development. And there was an even stronger support for this question. Okay, about most people said yes. Okay, so it means that in there it's very interesting because it's very I would say it's very cloud or third party. It means cloud oriented. Okay, so it's an opening of the ecosystem. Of course, for the OEMs, but also beyond the OEM, very likely. Then, very important question: are specs or implementation or both needed? Okay, and the question was worded that way. Okay, standard specification are only useful with at least one open source license reference implementation. Okay, so there was people somewhat or strongly agree with that, okay, and some people are not sure of what they could answer, and some people disagree, okay. So it's just a representative of the various approaches to automotive software development, I would say, but still. Having an implementation is considered as something useful. Then standard specifications are only useful with proven implementation for commercial entities. So then there was, I would say, more people saying agree somewhat, and other people say disagree somewhat. So the opinions were more, I would say, clear or more clearer, I would say. And if you think that these standard specifications are only useful with proven implementation for commercial entities, it's something like you know, the AUTOSAR approach, okay, where you have the specification are public and the implementation are I would say not in the public domain, as you all know. It may be someone similar to what W3C is doing, but Ted, I'm saying that under your control, okay? Because I know that for W3C you request 2 proven implementation for the specification. Was it correct, Ted? And then the last question was, is it better to only develop code instead of formal specification? So strongly disagree. So it means that people expect specification, okay? So it means that providing code and saying the code is a spec is something what was not very well supported by the people who answered this survey. And it's interesting because it's just present what the expectation from these participants toward this CVII work. So specification are the key asset and implementation are required. Okay. Any comment at this step? So I move on. So the second set of questions was about project awareness, okay, and company engagement. So we asked the people to rate their understanding of a set of technologies. So of course, the top one, the first on the list, is the vehicle signal specification. So everybody, I mean, most of the people have either from basic to advanced understanding, okay? So I would say that my interpretation of this is that we have a mature specification, okay? People have been looking at it, people have been implemented it already or on projects, okay? So we will come back on the later slide under what we can do for this, okay, to continue the maturity growth for the VSS specification, okay. Second was the vehicle interface service specification, okay, VISS, which is an implementation of some communication protocol to support the vehicle signal specification. It seemed there that we need to consolidate the understanding that the people have. Okay, so most of them say basic understanding, and very few say the advanced understanding. So we need to disseminate better what we have been doing on the VISS, and very likely on other protocol solutions we will be looking at. Then this vehicle service catalog, okay. Then there is it's very similar, okay. It's not a copy paste, but it's very similar. And I think that since there is probably a stronger number of people that don't know it at all, we should consider doing some evangelization. Of course, consolidation is needed, but doing some evangelization would be very likely to ease the access to the information. And then we put Franca interface description language, Franca IDL, because we are trying to understand how much Franca ADL is deployed in the automotive industry. It seems that there are companies, or I cannot say several, or I won't say many, but several companies using Franca ADL in their development process. Okay, and some people are the basic understanding. Okay, a lot of people don't. 30% of the people don't know it at all. Okay. And I think that we need to evangelize what Franca interface, Franca IDL is about. The Franca IDL has been around for quite a long time. Okay, we've already been working with Franca in GENIVI for many years. Okay, including rather recent development of Franca to AUTOSAR XML transformation. Okay, it was a project we showed. I would say 18 months ago. Okay, but it seems that we need to really make sure people know about Franca IDL, because it's part of the discussion we're going to have in the coming weeks and months. So I listed here some action in progress in order to improve the maturity growth or the evangelization of the consolidation. So I pick up some items. Slightly not complete, okay, and we can think probably later in the at the end of this workshop or in the coming weeks what should other action would be necessary. For the VSS, we have an action on metallurgy growth, and for instance, there is the joint works on VSS with the Open Insurance Network and ESIC Alliance, which is about putting VSS at work in insurance and SOTA domain. Okay, and it brings, of course, a lot of questions and a lot of questions on the specification, on how to implement the specification. And so it means that we will go to a next step of maturity with VSS, even though we're already at the VSS2 level, but we will continue on that. We have the work in the VL team, the VL team on the VSS to vehicle property transformation. So it was a very interesting work that happened during the first and second, maybe first quarter of this year. Okay, and it helped also bringing more maturity. And we are evangelizing VSS. I would say that there is two topics which we have one which has started recently, which is reaching out to ISO extended vehicle WG6. Okay, because those guys, they are looking at the data modeling, and we would like to share our thoughts with them, we'll see what will come out of it. But we were unable to initiate some kind of joint team on that. It's very informal. Okay, it's not official. It's just that people are willing to understand each other. And then, of course, reaching out to AUTOSAR, which is a very important topic for many of you guys. And it's all about, very generally speaking, VSS to AUTOSAR XML. Okay, we have already some experience. We know it's very important for you guys, and we are moving again on this topic together with AUTOSAR. VSSO, VSS autology. So it's we need to consolidate this, okay, because it's probably a little bit upfront with respect to VSS. It's a derivation of VSS, I would say. And there is some joint work on VSSO with Microsoft and BMW that was initiated earlier this year. And we need also to reach out to a CatenaX project, which is a European Union project on these the data modeling, I would say, for the automotive industry, but I don't want to tell too much things because that's not my major knowledge. Okay. VSC, consolidation needed. We need to stabilize the concept, okay, and we need also to evangelize the concept, okay, and you will learn about it today. I mentioned VISS already, and a way to consolidate VISS is to work on proof of concept architectural design and development, okay, because having code running is always very good to understand the way it works. And I would say we have also this Bosch IoT software, okay. There is, I would say, a very active work on GitHub, and we will likely investigate proof of concept work in the coming months. And I said for FrancIDL, one immediate thought is to have a wiki page with relevant info about Franca. Even though it's hosted in the public, it could probably help to have some quick links to look for the information. So this is why from these analyses, we came up with a proposed agenda for today. And sorry, Gunnar, if I duplicate what you will present soon. We chose to talk about VSE and the industry common service interface language. And for the VSE language, we'll talk about FrancIDL, OpenAPI, async API, okay? Alignment, so ISO extended vehicle specification. So you will get a report on the status of this work and what could come up in the future from this. Tech stack, AutoSAR, so we will discuss the planning for connected data and service models to common data model, okay? It's a very important topic. As I said, we showed implementation in the past, but now we are probably 18 months after this first demonstration. We need to rethink it again and rethink with the latest thoughts on this topic. We will have a presentation of AOS, which will be an overview of a cloud and vehicle framework that is proposed. That is a possible implementation for the CVII, okay. And we will have eventually a discussion on the CVII technology stack, which is the project that there is a weekly call on Wednesday evening, and there are currently, I would say, a lot of people joining this project because the most recent statistics that we have between 15 and 18 participants every week. So then question about the company engagement. So people said that they are engaged only in 1, 2, 3 activities. It would be better to have more engagement. Okay? Not more engagement for the same people, but more engagement for several people of the same company. Okay, it's a recurrent topic for a collaborative project, as you all know. And then we ask about the which CVII related area would you consider engaging if you can and could commit some of your time. And the best in class are the improvement and aligning towards common vehicle data description standards. Okay, so it means the meta models. Okay, how do you describe the vehicle data? And the second one was vehicle to cloud standard protocols and implementation. Okay, I don't want to detail the rest. You have the slides later. Okay, but this is where we could expect people to engage in the future. Okay, thank you.
Okay.
For questions, so we just jump directly into the technical stuff.
Yes, I'd say so. We don't have too much time, so.
Okay.
So
gonna share
just
screen.
yeah, 1 second. So I don't see my own sharing. Am I sharing?
No, and No, you're not.
1 second. Still not working.
I have issues sharing as well, so I think it's actually today WebEx.
I'll try sharing window instead of screen.
Okay.
Still nothing.
Or you have two instances. Which one are you trying to? Are you trying to share from the host device or from the other device?
Okay, it's from the other device, but I didn't know there was a restriction.
Okay.
Shouldn't be, hopefully. Okay.
I, for some reason, cannot make you a presenter on that device. I'm not sure why. Can you? Okay, you made yourself co-host. That should work.
I think that's not the issue. So I have the share button, but once I'm clicking it, it doesn't seem to go through. Okay, well, let's try to move on in the agenda. Next topic in the agenda is to talk about the vehicle service catalog. And really, I can just mention verbally the housekeeping point I wanted to make was that CVII, of course, has a major, large scope, and I know we have some new participants today. This workshop will not have an introduction to CVII, so if you look at the different topics we are covering, they are selected for this specific workshop and different from other workshops, and so it may seem a little bit scattered for that reason. We now want to talk about vehicle service catalog because we've talked a lot about data standards already. That seems to be very established in the industry, the agreement, general agreement towards a common data standard. But now we want to talk about service APIs. And if you try sharing, Magnus, hopefully it works on your side.
Okay. Sharing screen one, share. Slideshow, start from first slide.
Yeah, that seems to work better.
Yay, first try. Okay, please go ahead, Gunnar.
Yeah, I'm not seeing the full screen though.
Oh, crap. Or let me do an exchange. Oh, that's the wrong one. Do an exchange again, please wait.
Just figured we should have it a little bit larger.
How about this?
There we
yes,
go.
Finally.
Great.
How about that?
Okay, let's go. I will do the first introduction slides and then hand over to Magnus in a little while. If you go to the next slide.
There we go.
Yes. So this is the basic question we want to cover today. How can we describe a set of vehicle and connected services that use adaptive, open API, dbus, etc. as a single uniform system? We will go into the details of that, speaking about the description language. Let's go to the next slide. First question that may pop up if you've looked into the work we've already done and some of those description formats is, of course, do we need a new interface description language? We'd like to go through a number of different points here. First of all, as we progress this discussion today, you may see that it's perhaps not really a new ideal, and that depends on where you're coming from. If you're already a seasoned Franca user, then you will see that we're looking to basically build on all that knowledge that Franca has already created. And if you're more looking at coming from, certain ideal that is used perhaps outside of automotive or more generically, you may think, why does automotive really need to create its own solutions? And if you haven't seen Frank IDL, then you might still be in that mindset of thinking this is something new. So depending on that, we might say that it's actually not a new ideal, but some of the arguments for why we think we need to do something are listed on this slide. First is to capture all the needs on the automotive systems, speaking about the entire scope, as we often do in CVII, the in-vehicle work and the cloud work. Because just like for data, the advantage of having the same standards and the same ways of doing things will be more and more seen over time, since their systems are so connected. So we're looking to have one ideal to cover all of that. Franca did a great job in that. A lot of thought has gone into Franca, and especially that fundamental point that it should be possible to cover all types of interfaces with Franca. What we do want to do is create a new, flexible and lightweight tool suite. We think that there's improvements to be made in the area of Franca tooling, and so with this new IDL or Franca alternative IDL, as we will get into the details, that will be the basis to improve the tools situation. We're also looking at the formats, and if you look at the standard data model right now, it's heavily leaning towards being started from VSS and based on that and built from that. And therefore, we think if we can mimic that in the creation of the common IDL, then we would be able to create both a solution that fits well with VSS and also is very consistent from the perspective of the formats. And that's why, for example, a YAML-based description format has come up as a really important contender for this. Furthermore, in order to have standardized services, catalogs of services from GENIVI and other sources, we need at minimum to agree on a single IDL. Maybe that's not an argument for a new IDL, but it is in combination with the other arguments, basically an argument for a new IDL. And once we've done that, we want to promote gradual industry movement towards a common language for describing the behavior of programs and subsystems. So that's the basis of the whole work. And the final points are basically, again, capabilities that we will get out of this. Again, not in itself perhaps an argument for a new IDL, but definitely an argument for working in this area and agreeing on a shared IDL. So auto exporting services, from just to leverage tools that we've created together, we're able to export service descriptions from your existing interface descriptions to this new IDL. There's also the planned ability to connect all of this to protocols that are automotive specific. And examples, of course, are ARXML, DRPC, protobuf, some IP. All of these listed parts should be included, and we should be able to basically convert or code generate between them. We'll get into those details a bit more. Next slide. I have to be aware of the timing here since we're a little bit late.
Shall I do this?
Do you want to take this over?
Yeah, I can do this. So I'm Magnus Foyer, by the way, in case it's not obvious. I'm looking a little bit more at the tooling side of things, trying to figure out what the tool chain will look like in order to support the statements and proposals made at the previous slide. So as such, we are still trying to figure out which is the master format. Are we going to use FrankIDL as the master format, or are we going to use this vehicle service catalog, which we started to define as well, which is just a YAML schema pretty much, as the normal format? In any case, we will need to support existing IDL libraries out there, both that are maybe publicly available, but ahead of all things that are used internally, which we know is there's a fairly wide industry adoption of fiddle files or FrankIDL across the industry, across multiple OEMs, although not many talk about it because it's usually a proprietary development. So what we will need is a strong support for FrankIDL, regardless of which role Franka has in our kind of end game, to convert that to different formats without semantic loss, because we don't want to lose, for example, error codes or some of the finer points in the fiddle file when we translate that to either a standardized kind of VSC format, which is the right-hand HVAC YAML file. So that would be the vehicle service catalog format. And also, if we support other input formats, and we have those grayed out here, ARXML, Proto, etc., we need to make sure that we retain as much, or actually all, of the semantics of these input files, which means that a YAML file on the right-hand side, a VSC file, needs to be almost a superset of all the things on the left. Luckily, semantically, all the things on the left, some exclusions on ARXML because that's a very wide spec, they're pretty much describe the same things. You have events and you have RPCs and you have input and output arguments and some error codes, etc. So it's those formats I've looked at, it seems doable. The important bit here also is that as we start to kind of create a new set of tooling for FrankIDL, a new generation of tooling, which is more command line oriented, and we already have a full FrankIDL parser written in Lark, which is a Python-based parser system. We, as we start to create this, we will now start to support more of a CI/CD, continuous integration, continuous deployment system, where you can actually do these kind of conversions, code generations, etc., in the cloud. And that in its turn, as we start to kind of broaden a little bit how we use Franka, and also as we start to integrate additional protocols, may drive Franka to the next step, where we update the Franka spec itself, the Franka format itself. So I think that's it. We still obviously haven't decided on a name for this IDL, where we see this placeholder $, IDL name. So that's not an omission on our end. It's actually kind of an invitation to discuss where do we want to take this. We're starting to see pieces come together, but we still don't know which pieces we want to put where, and that's where we need your input here. I was almost going to say next slide, but then I realized it was me. If you look at OpenAPI, we see that as just yet another IDL format to integrate with. Either we can read OpenAPI YAML specs and generate different kind of APIs toward that, or we can take FrankIDL or whatever input you have and generate an OpenAPI specification from that as well. We just see this as yet another thing in the, call it IDL ecosystem, that we need to integrate with. And the key here is that we really don't want to reinvent the wheel and recreate through duplicate effort what OpenAPI already does. If OpenAPI does something well, such as code generation or web integration, etc., use that instead of trying to write it again. A sync API is, from our point of view, similar. It's a little bit more VSS targeted or overlapping because it's a pub subsystem and it's backed by MQTT, etc. So we can integrate that as well. It ties a little bit into the question of VSS versus the vehicle service catalog, and how do we integrate those two? Do we want signals to be a part of the IDL file, or do we want to keep the signal spec completely separate from the IDL file itself, which is really an open, almost philosophical conversation that's going on here. And here is an example how we can integrate OpenAPI. We take our dear old HVAC example because it's so easy to understand and it's no proprietary information or anything. It's well understood. It's pretty much a common thing. So what we can do is that we can take the HVAC Frank IDL file, use the converter in the second arrow, IDL name convert, to call it normalize the convert it to an Open API YAML file. So, and we can either do that directly, or we can do it through an intermediary format, which is not shown here, which would be the VSC file. So we can almost use the VSC format as a intermediate format, almost like an object file or an LLVM file, if you want to play with that. So once we have done the automatic conversion from Frank IDL to Open API with full semantic carryovers, we don't lose any information. We now use the Open API generator, which is a part of the Open API toolset, to generate the relevant REST server. And in this case, if we want, for example, bring your own device, where we have a hotspot managed by the infotainment system, which is the standard solution that the phone now connects to, that hotspot will now expose an auto-generated HVAC REST server, which, and this is the important bit, is generated not by GENIVI and W3C tooling, it's generated by the standard Open API generator tooling itself. At the same time, the HVAC service in the infotainment system can have a second protocol auto-generated, which is the standard path for HVAC to Common API. And that will now support integration to the HVAC ECU itself through some IP or whatever you run in the vehicle. Single specification means that you have a single source of truth, and that also opens up for testing. And I do think, having looked a little bit closely at tests lately, that test is going to be a driver of this. Once you have a single source of truth for how the system behaves in whatever IDL file you have, and you can now generate multiple different endpoints to that, be it Open API, be it Common API or other things like that, you now start to enable testing in a much earlier stage so that you can actually automate, bring your own device testing, cloud-based testing, system integration testing over some IP at a much earlier stage than the more traditional place where, oh, we finally have a prototype vehicle or we have a lab bench up and running, let's fire things up and see how it works. When you come to that stage, integration testing should be done already. It should be done in the SIL and in the cloud as early as possible. And the key to that, I firmly believe, is to focus on the interface and the API and the call flow between the components. And the key to that is to have a normalized or standardized interface format, such as an IDL file, like you see on the left-hand side. So we have two versions here. We have a wide plethora of non-vehicle based IDL files and ecosystems, which are usually more targeting both either web or mobile or both these days. What is not that much, we do have a bit, is generating in-vehicle code. How do we generate code that actually targets the vehicle itself? So here's where the normalization comes in. If you have vendors or legacy systems, etc., that uses adaptive AUTOSAR with ARXML files, you have some stuff written in Frank IDL, and you may have some, things written with gRPC or protobuf. You want to be able to normalize that into a format, HVAC.YAML in this case, which is the VSC format, or this emerging IDL format we're talking about, so that you now from that can generate various code stubs and have that, and these code stubs are obviously targeting the vehicle itself. This allows us to retain our existing library, and we don't have to do a forced upgrade where everybody has to move from ARXML to Frank IDL before we can do this. You can pretty much retain your source format and migrate as you see fit, and then still have the ability to generate multiple different endpoints depending on what you want, which you can then deploy in the vehicle. On the opposite of that, or the other side of that coin, is the non-vehicle code, stuff that kind of runs outside the vehicle or sometimes run inside the vehicle but interfaces the cloud or mobile devices or something like that. In that case, we do a two-stage convert. we convert to the normalized format, YAML, the service catalog format, HVAC.YAML. Again, no semantic loss. We have retained all the information that we need. And then we run a second stage converter, which just converts VSC in this case to protobuf or OpenAPI YAML files, etc., that then continues to feed into the chain of the standardized tools. And this is what I spoke about earlier, where we don't want to reinvent the wheel for OpenAPI, gRPC, and everything else that's out there. We just want to find a way to integrate with them, link to them, and then hand over our generated specs to them and go, you know the code generation better than we do for these different things. Please do that. And I think this is you, Gunnar. Do you want to take over? You may be muted.
Yeah, sure.
Yeah.
Thank you. Yeah, I just wanted to recap a little bit what we talk about in CVII as a whole and how this connects into this work. And so overall, of course, CVII drives the conversation. We're trying to drive the conversation as widely as we can around the alignment of core standards and technologies. And then within that, we have something called this tech stack, and that sort of assumes that we will meet the track of standardizing the data model and services model to some extent, and to that extent we can then start building a technology stack together that uses those basic models. In the end, we want to select and align on a reasonable number of protocols and technology bindings. So to summarize, I think the approach that Magnus has gone through here, the first is to develop, in quotes, meaning to, of course, reuse existing ideas, existing technologies, but agree upon a full-featured IDL with heavy influence of those existing choices that are there. And the second is to provide the tools and bindings, so concretely create new tools and code generators that don't exist today, with a new and simple and extensible approach. The third point is create conversions where it's appropriate, and it is appropriate in those cases where we want to leverage existing ecosystems and implementations, like Magnus gave concrete examples of. So just to generalize that principle a bit, it's that's when we create the conversions, is when it's necessary for a smooth migration over time, maybe because of companies' current investments, and for the reason of leveraging what is already there. And then while we have done that so that systems can be built, we can over time promote the movement towards a single industry standard IDL. And that will, of course, be a more of a longer term goal. But there's just tremendous advantage to be seen there if we can have a common language, the way to describe all the behavior of the different subsystems, whether it's inside of companies or between partners and buyers and sellers of technology. Everyone speaks the same language. It just will simplify the interaction greatly and put the effort on interesting functions instead. And so I wanted just to clarify, as I think we've done with the examples, that it should not be an everything to everything conversion approach, because that will, of course, create choice and opportunity, but it will also continue the fragmentation we have. So we want to find the right balance where we reuse and convert to things that exist, with being very diligent and thinking about where to do that. And through that, I think we can strategically avoid a kind of XKCD effect on this creation of potentially a new IDL or a derivative IDL of Franca. So that's just me trying to give the big picture over this.
Yeah.
And I hope that was useful.
So this is the last slide before we come to open questions. So this is a proposal of how, as an OEM or as a player, agent inside the automotive industry, how you can adopt this in kind of an incremental way. And the key is always to start with what you have. Don't try to do a forced conversion and pretty much force a new set of tools on to replace an existing tool set that may not be the best, but that actually probably works at this point and is somewhat mature and especially predictable. Keep your existing library and start with that, and then use automated tooling to normalize these IDL specifications to the VSC format. And from there on, you can now do the code generation, as I showed with Open API or Common API or whatever you want. But you now have a broader set of output formats and a broader set of tooling available to use to generate code from your IDL file than you probably have today, whatever that current IDL specification format is. You can also now start to be more flexible when you talk to your tier 1s or tier 2s, and they start to provide IDL specs and service-oriented architecture deliverables with their specifications to come with that. So you don't have to force them to rewrite their IDL specs because they have their own ecosystem. Instead, you can accept whatever they have and feed that through the normalization chain and tool generation chain in order to integrate both their interfaces, but especially their underlying implementation with their own protocol interfaces to your own vehicle or to your own system that you're running. And again, as I mentioned earlier, I think a key here is that you can now start to use these IDL specs, regardless of format, to automate tests for multiple service protocols that interface a single service. HVAC is a good example, where we, in the example, both had a SUM-IP interface and a Open API interface. It's pretty much the same service. It's just different ways of accessing it. And this is one step that I see where we start to remove the boundaries between the vehicle and other entities, be it mobile phone, be it the cloud, be it the head unit itself or the infotainment system itself. They all want to do the same thing, which is to set the temperature, and is one service to specify that. But it's only a question of the underlying protocol, security, robustness, safety. So why not use a single spec in order to enable to test all these different interfaces from a single point instead of writing 3 different tests to pretty much test the same service through different protocols. And then finally, the adopting entity, whoever it is, now have a choice. Either we continue with our existing IDL specification library because we do like it and we want to keep one format. We can start to write new specs when new services come in or we do major upgrades in the VSC format, which is the intermediate or YAML format, and then we can gradually kind of retire the original IDL format, or we can do at one point say, now we're just going to do an automatic conversion for everything because we've proven ourselves this works. Let's retire the old IDL format and go all in on the new format. So that's it. Now the next slide are the open questions. Again, we wanted to approach you all earlier rather than later because there were a lot of questions that popped up almost on a philosophical level, and we would very much like your input here so that we can continue to drive this in the right direction and not sit at home with a bit of navel gazing and make a lot of assumptions that turn out to be incorrect. So these are the open questions that we have. And Gunnar, do you have anything else to add on this?
No.
Okay.
No. I mean, we want to have we have some time. We have at least 10 minutes or so to talk about these questions, just so that we will have a break in just over half an hour from now. So maybe 10 minutes of further discussion on this topic, and then there's the ISO extended vehicle current state and future plans, which I'm looking forward to very much. So
I can start us off with a question. If you go back to slide 8, and by the way, this is Jeff Dever from Ford. Yeah. Just looking at the in-vehicle flow. Right. So this HVAC FIDL and HVAC AR XML. So both feeding into VSC convert. So one approach would be to have the FIDL generate AR XML,
yes,
right, from Farrakhan, and then from AR XML, then really you've got sort of an AUTOSAR approach, right? But be able to accommodate not just what was in the Franca, but potentially other things, including things that are difficult to describe in Franca, like deployment type information. So interested in your thoughts on that flow. And just to follow on to that would be FIDL does have the potential of using structured comments or sort of Java-like annotations, and that could be a potential Franca-only solution rather than using an intermediate YAML. Interested in your thoughts on that too.
I can start with the comment bit. I've written a full fiddle parser, as I said, and we have the ability in that to extract the comments as well, the structure comments, and retain that structure and drop that into the YAML format, HVAC, the VSC YAML format, which is still very much being defined. There is an ongoing conversation. It's not been much action during the last week or two, but we have a general agreement on how to move forward on that, and we will very likely add structured comments to that one as well. For ARXML and deployment or network topology, that's a tricky one. Having done this a few times now, I believe, but I'm not convinced that we want to separate interface definition from the deployment model itself, which is a little bit what FrankIDL has as well with deployment files, and what very much HVAC, the VSC standard, supports as well. With you can augment the core IDL definition, which focuses only on input data, output data, and what does the interface surface look like, or the API look like, and you can now augment that with deployment model build time, because as you provide the deployment model, which this ECU is going to run this and this ECU is going to run that, that's when you fixate all the services and you want to generate a set of firmware images that you can now drop into your various ECUs in the vehicle, and and have verified build time that all the services are available, they have the right version. When this vehicle comes up, ignition on, whatever power mode you have, everything will be there and it will work. So we have the infrastructure in place, both in the fiddle and in the VSC format, to support those kind of augmented deployment models that you build time kind of add on to the IDL file or the interface definition to get the deployment that you want this run up in the cloud, or when you generate the image. Does that make sense to you?
Yeah, it does, and I think grappling from interface definition and deployment details, there's some that are clearly on one or the other end of the spectrum, and drawing the line in between is necessary one way or another. So yeah, I'm interested in seeing more and hearing more about the intermediate YAML format.
There is a service. If you go to GENIVI and look at vehicle service catalog, there is kind of a trial service that we use as a discussion basis there on GitHub. Sorry, so github.com/GENIVI/vehicle_service_catalog. I hope I memorized that one right. And there's a trial service there with, I think, a number of tickets. Oh, thank you. Where we kind of use a seat service as a discussion example, and we try to pump as much crap into that seat service as possible so we can try all the edge cases, etc. So that's the current state of thinking. The code that I'm writing, which currently can, as I said, fully parse a fiddle file, and I'm about 50% through to do the VSC convert, literally the gray box that you see in front of you right now, to HVAC YAML file. That's still in my private repo because it's not ready yet. But as soon as that's done, we're going to move that over to GENIVI so that we can continue to work on that. So the YAML format itself for the vehicle service catalog and its tooling are kind of evolving in tandem at this point. What we need now, I think we have capacity to kind of complete the tooling, but we need your input, exactly questions like you asked now. That helps us kind of guide our effort towards something that is useful to the wider industry.
Yeah, excellent. Thank you, Magnus.
You're welcome.
Hi, Daniel. One question. If you go on slide number 7.
Wait,
you said Krempler example. How it would be in your...
1 second, I'm trying to figure this one out. Come on. Oh, here we go. It's just very slow. There we go. Yes. Can you see this?
But just the question is just how you see the set temperature. What would be the input parameter?
So the input parameter from that, if we use a REST server, would obviously just be HTTP REST according to the OpenAPI YAML file, and that would probably centigrade. And in Common API, if needed, that's where we convert that maybe to a bit field, if it's 0 to 255 or something like that, and have that out. So that's where you probably are going to have, in this case, a fiddle deployment file that describes the conversion data that's needed.
And this my question would go more in the direction. It's like, is it a VSS signal or like, or do you see just an integer there? Because I mean, you lose here the complete semantics, right? I mean, like, what is the temperature? Where is it? Where is it in the car? I mean, and that's what is basically specified in VSS. Like, is there a combination plan there?
So that's now we are touching on a very big, well, call it 800-pound gorilla. What do we do with VSS versus everything that we spoke about here today? You're absolutely right that the temperature could just as easily be a VSS signal that's settable. And in this case, it's actually intended as a command. And I still cling a little bit that you actuate through RPCs and you report through signals, which I stole from telecommunication. So that if you're going to change anything, be it a actual actuator or your dome lights, or ambient light, or FM station or whatever, then you use a command and then you report back. However, there are very good arguments against that, and we've had a long conversation about that. And I don't think we're absolutely in alignment or in agreement on that yet. But the big
unresolved, in that case,
go ahead.
Even in that case, Magnus, you would be able to reference which VSS signal you wanted to affect.
Yes.
So I think there's more discussion on the how we describe the combination of the VSS and VSE models.
Exactly.
And I hope all of you who are interested join some breakout sessions on that, so we can really pound these things out and get to a conclusion.
Especially with the conversion you had at the beginning, no? Like, I mean, like, we are fighting with VSS exactly against that, no? Like that you take the RxML, which is there now, because a lot of things are not described in the way we would like to see it, no? Like, and there is where you say, okay, like, there is some abstraction at some point. Of course, the closer you get to the signal and so on, I agree. It's like with the VSS, or with maybe with the if you define a catalog of functions, it's as well good, no? Like, but if you open the possibility to take basically everything which you have right now to basically to shift it to to the complete right side of the cloud, no, that is like for me like not the nicest scenario I have in mind. No? That's as well the question, like how do you do the abstraction and like where VSS plays a role, because I think it's really
no, it's we haven't solved that yet, and we know that we need a well-defined interface and integration point between VSS and VSE, but that design, not to mention implementation, remains to be done. And we will, I think the best way to approach that is use cases like this and go, okay, which different ways can we do this specific use case we're looking at here? Do it as VST only, we do it as VSS only, or can we do some kind of integrated mix between the two?
I mean, in this case, for example, nothing would stop you from using like even as an input parameter reference to VSS, or like even if you name it.
I think we should just see this as an example, Daniel.
Yeah.
And not get too hung up on maybe temperature should be handled differently than shown in this picture. But the key point is really here about the tooling and the different formats and how we can generate things out of that. And we do know that there will be services that need this tooling that may not have a relationship to VSS. So some of them will be simpler, but we do need to solve that combined relationship, as we said. Probably won't have time for it today, unfortunately. So
that's a long discussion.
I think we want to open up, see if there's any other questions. I should also mention that we will talk more about AUTOSAR later today. It's in the planned agenda. So the whole discussion about how to convert perhaps AUTOSAR interfaces or connect to them might be also had there if we still have time.
Maybe one question from me. on the slide 8, you are showing that actually you are translating different formats from RxML, Franca, or anything else into common format and generating different APIs out of that.
Yeah.
What if we can do it other way around? So having one specification in this, let's say, YAML file, and then generating each API by the tooling for a specific format.
Yeah.
So the fiddle can generate, let's say, the common API, RxML can generate RxML and stuff like that. So then we can reuse the code which is there and not create everything from scratch. But still,
do you want to answer this, Magnus?
I can give it a shot. Yes.
I think it's a quick answer.
Okay, well then I'll let you answer it because you're
this is basically the end goal, isn't it? I mean, if we could establish a single IDL to describe all and use only that to describe all services and behavior in the system, that would be ideal. But what we are discussing here, I think, is a path towards that. And this particular slide deals with the fact that you already have definitions that you may want to reuse, and then you need to convert them to a common format. But what you mentioned is exactly right. I mean, it's almost like the fundamental point is to if you were able to describe everything in the single IDL and generate these different technologies, and that is definitely something we will work on. And you will see when we talk about AUTOSAR some examples of proofs that have been done in that direction before. And so,
but the point is, instead of generating from the common model, rather translate to different models and then generate the final code out of these models, because then the tooling is there already. And
but this is the different slide that we covered, right? Which is
so that's slide 8.
I mean, the alternative approach is to reuse existing code generators, which we also highlighted. And then you convert to the other format because you want to leverage that technology that already exists. So that's definitely also part of the strategy.
Yeah. So
sorry if I misunderstood what you said first time. You seemed to say that you were trying to have one IDL, but one starting IDL and then multiple generation paths. So this was actually covered already.
And there may be a couple of variants here that we did not cover, but I think we can use.
But the principle is there.
Yeah. So it boils down to the main question. One of the main goals here, or almost the main goal, is to create a service catalog with a number of standardized, non-differentiating services that we then can use as a set of best practices in the industry, so we don't have to reinvent, yet another tuner API. And the core question is, which language do we use? And according to the question that was just posted, and sorry I missed your name, if we use the VSC YAML format as the centerpiece and define the services in that, which is fully capable to do, and then translate to FrankIDL, ARXML, etc., in order to leverage existing tool sets or whatever you have, that's very well. And that's one of the main kind of options we're exploring. But we don't know if that is better or worse than to leverage FrankIDL as the reference format when we define the service catalog. And it's like, okay, we're going to develop all this in FrankIDL. When you submit your proposal to standardize, automatic cruise control, please do it in FrankIDL. The upside of that is that there is a wider adoption and, quite frankly, brand recognition of FrankIDL. It's proven, people are using it, it's in production, etc. But we may now lock out a lot of people that are ARXML focused and don't see an easy way of kind of translating that to FrankIDL. VSC is a more flexible intermediate format because it's YAML and it's designed with this specific conversions in place. And we simply don't know, which is why it's an open question as well.
For me, the goal would be actually also to let those different formats at the end communicate with each other. So if one part of the system is described using Franca, then the other maybe could be described using RxML. And if we've got the common format, then maybe they can understand each other over a common bus.
Yes, and that's a definite goal. That I want to take my Frank IDL file. I'm going to make stuff up now. I want to take a Frank IDL file, and I want to take another service written in ARXML. And you know what? At the end, I want to use dbus as the communication protocol. That even if we don't support that specifically, we definitely want to be able to enable that. So, but it's a double-edged sword, because we come back to the risk that, hey, everything is possible, and now suddenly we just have more fragmentation where people take this to extremes. So we really need to figure out where we draw the line. Maybe not as much in the flexibility of the tooling, because that will probably be there, but more in how strict are we going to be when we start standardizing things, and what do we want to support on a GENIVI W3C basis. But the conversion tooling, still early stages, but the VSC format itself, the YAML format, and the parser and tooling we started to work on definitely has the potential, call it that, to do pretty much free format conversion.
Magnus, the only thing I would add there is the incremental scope of making it easy, or at least having some level of documentation for a third party to come in and create their own conversion to another standard would be a nice boundary diagram for this type of approach, because you're still going to have churn within the auto industry where everyone's got their own little proprietary space that they want to hold on to. And if they want to spool up a software developer for 6 months to go write that interface so that they can make that translation, then, at least make it easy, reasonably straightforward for them. And then you get broader adoption.
They're also welcome to come and affect the direction, right, John? The direction that the sort of standards are going. They're all very welcome to affect those if they have personal interests. So I think it's a balance between those. As Magnus said, there's choice and flexibility. That's good. But there's also a movement towards a bit away from the fragmentation mayhem, right? So we're trying to balance that together.
Yeah, agreed. I mean, it's how do you make that progression happen in a controlled way?
Yeah, and to answer your question, the parser bits and pieces I'm writing right now has a built-in parse transform mechanism. It's all written in Python, so where you pretty much can take an input tree and transform it, input parse tree, and transform it to an output parse tree that has the structure of, for example, ARXML, and then we run it through Jinja, or probably Jinja as a template generator, which is then going to be almost like a straight output filter to convert to create the right XML structure, or XML content rather. So we are targeting that conversion. We want to make it easy for the 6-month contractor to write that plugin.
Yeah, I mean, generally it is easy. It is easy to take the examples and restructure them for your own purpose.
Yeah,
I think that's going to be not a major sticking point. So.
Okay, thank you.
We have to move on in the agenda. We're a little bit late. I'm very happy that we have so much interest for this topic. This is one of the first times we really raise it in this type of workshop setting, and say that now it's time to really get dug in and work on it. So please keep in touch, and we will set you up to participate in some breakout meetings, hopefully, going forward.
Yes. Yeah, thank you very much, all of you. It's been, I'm glad that both in the survey that Philip presented, there seems to be a very strong need for this, and I'm glad that at least in our initial very, very early step that we presented here, we seem to be at least wandering in the right direction. But again, we need your guidance and input here in order to get this right.
Yep.
Oh, I hope that's not.
And now I think my sharing is working for it.
Yay.
Finally.
Okay.
I just had to reconnect to WebEx apparently. As you can see, we're a little bit behind the schedule. I want to turn over to Florian, talking about ISO extended vehicle current status and future discussion. Then I hope we will have time for a little break. Everyone surely needs that. And then we will talk about a bit more detailed about the AUTOSAR related connections. I think very similar discussion to the ones we had, but more focused on AUTOSAR specifically. We want to have time to go through AOS, which is a really exciting framework. And if we still have time, I will try to tie all of this together, talking about how we build the CVII technology stack, referring back to these examples we have seen. So, Florian, please take it away.
Yes, I can do so. So,
stop sharing.
all right. So you should be able to see my screen. Nice.
Yes.
And you can hear me as I see. Beautiful. Works like a charm. Good. So, as Gunnar mentioned, thank you very much. My name is Florian Pinsel from Technology Planning Department at Denso, Germany. And I would like to give you some quick introduction to ISO Extended Vehicle today within the context of the CVII. And with that, yeah. Why do I want to do that? Simple reason is because although I don't follow the CVII discussion for not that long, I very much agree with its objective. I started to see overlap right from the beginning, from what we are missing and from what you are investigating on. And that is, simply speaking, the support of multi-brand use cases with independent vehicle data descriptions on a semantic level. And on semantic level, I mean, either it can be model or ontology or classification, but really the description of it. So not a specific data set or specific list, even if VSS can provide that already, but rather the description or the organization of modeling. So in the end, also ISO Extended Vehicle is looking for a way to provide some consistent understanding of information units. So
I'm hearing some dropouts.
Yeah, here too. Sound seems to be broken.
Dance and
Me too.
Yeah. Okay, Florian, you have to go back about 30 seconds because you had dropouts there.
Oh, sorry.
Are you there, Florian?
Yeah.
It's okay. It was just a bad connection for a while.
Oh, very sorry. So okay, 30 seconds back. So yeah, just mentioning that also ISO Extended Vehicle wants to provide consistent understanding of information units, and within the CVII, you can see that we are located in the alignment track, and therefore, yeah, don't expect too much technical detail today, but rather overview and summary, where are we standing currently and how we potentially could connect to your activities from GENIVI side and W3C side. Good. So extended vehicle, we see the following situation. All the OEMs have equipped many of their vehicles with telematic units and also built up IT infrastructure to handle the data connectivity between vehicles and backend systems. You are all aware of this situation. And what extended vehicle now does is that it basically virtualizes the data communication from the vehicle at the IT backend system. So in that sense, extended vehicle provides system design overall, but also specific guidelines and requirements to allow external parties the retrieval of OEM data through web services. In that way, it supports also the access to registered, authenticated, authorized parties by utilization of specific frameworks. I'll come to that in a second. And from technical viewpoint, it is basically speaking a server-based API, which does support a reusable data format. Very easy. But on the other side, there are a lot of things that are not specified within extended vehicle. So we don't define a specific hardware system. Also, the means of data collection are not specified. And what is most important, in that context today of CVII, it does not specify any form of specific vehicle data, nor a data model or some other way of organizing data as a topology or classification. So this is, once again, the reason why I think it's a good idea to give you, some overview to start discussion here. So quickly looking into the
broken again, right?
Yes.
extended
Florian,
vehicle.
we have some audio issues again. Can you hear me?
Yes, I can hear you.
So 30 seconds back again. You were fine in between, but there was a dropout just now.
That's, I'm sorry.
Go ahead.
So probably,
don't be sorry. Just go ahead and back up and we'll be fine.
Yeah. Okay. We will repeat that probably for a couple of times now, but feel free to, just speak out whenever that happens. So all good. So yeah, as you see, 3 standards here. ISO 20077 gives like the overview and background information and defines a terminology. ISO 20080 provides a first concrete use case for extended vehicle, namely remote diagnostics. And within that standard, we actually find some description of what kind of data is necessary to provide that use case. And last but most important one from my perspective is the ISO 20078, which describes the technical aspects of the communication interface. So, and as a side note, we are currently in the 2nd edition of this, standard series describing the interface from technical perspective, and you can await its publication within, let's say, the next year. So it might be even around change of calendar year sooner or later. So with a look on the technical aspects of the 20078 series, you can see consisting of 4 parts: content, access, security, control. And below you see the, say, quick summary of the most important technical parts of it. So obviously using HTTP as transport protocol. For service design, it only allows a RESTful implementation or RESTful design. Recommended data format is JSON, but XML is also allowed. And for authorization and authentication, OAuth 2 and OpenID Connect frameworks are defined within the communication standard. Okay, so as you see, as you can feel, actually nothing too fancy here. Most of you are probably related to most of these technologies or frameworks. And this is actually one of the benefits of the standard, that you don't have to acquire a huge automotive background, but it's usually enough to understand the standard to some extent if you have some web development skills. Okay, from perspective, what has happened recently in the second edition? I'm not going into too much detail here, but see it as a just plain information for you, what we added in the second edition within the last year or more. Push messaging was added additional to traditional request reply. Also, advanced error messaging was introduced to the standard, describing some specific response codes for clients. And there was also the introduction of container management API. In this context, we speak of containers as a set of resources configured by the accessing party or service provider. So they have the chance to sort of combine their wished resources into a container and then request this set of resources as a set and not individually. What may be interesting for you, since we touched on it in the talk of Magnus before, this API, the second API, is specified with Open API specification. The communication API, so the actual API of the standard, is not specified as Open API.
Oh, now there's a problem again.
Yeah.
Let's check the audio, Florian. Are you there? It's very choppy.
Okay.
Maybe we'll give it a few seconds and it gets better again.
Okay.
Testing, yeah. I think you're back. Are you there?
Yeah, I can hear you perfectly.
Yeah, now you're back. 30
Awesome.
seconds again. So we should be fine. Go ahead.
Okay. Okay. So looking at some, let's say, high-level advantages and disadvantages of the XP concept, we can summarize as follows, as an intermediate summary, so to say, not what is my more or less be like a almost political high-level look on it. What this standard has to offer, what is advantage, what its advantages are and disadvantages. So points of contention, of course, we still see, after all, a strong dependence on the manufacturer to provide data in the first place. We have a unidirectional communication, so kind of read-only communication. And also, since there are no requirements formulated, since this is application dependent, we don't have real-time access to vehicle data. So these are some, let's say, disadvantages or potential points to discuss in the future to improve. But you will see in a second that this discussion is led by many stakeholders. So yeah, always have to find a compromise. But there are
Lost you again. Hello, Florian.
It's
Florian, I think to continue, go back again. After you said it was a compromise, we lost you.
okay. That's horrible. But honestly, I have no idea how to improve the situation since I'm already connected via cable.
I think we just finish up. It's we're getting towards the end of the slide deck, right?
Yep, correct.
Yep. So you said it was a bit of a compromise, I think.
Yeah,
exactly.
exactly.
There.
Yeah. So just saying compromise between all the stakeholders, but you see also benefits and advantages within the standard. Yeah, depicted at the bottom. So we already mentioned small automotive know-how that is required, limited interaction through some self-registration process by the service provider on OEM side. And last one is a very political statement that extended vehicle in general supports a non-discriminating approach to data access. Okay, so some colorful slides to end this overview summary. Here you see all the stakeholders. So what I try to say with this, that the necessity for an open and standardized access to in-vehicle data participating in standardization and other automotive associations. Might be interesting for you to see that the standard already find some ground. We see a lot of implementations from stakeholders already, especially from OEM side, obviously. So this is a small selection of available APIs which follow the X3 concept. And a small note on my side, I can't guarantee that all of them are fully compliant to the standard, but I assume that most of them are more or less. Okay, and now leaving the, say, general part of extended vehicle, building the bridge to the activities of GENIVI. As I said a couple of times, ISO extended vehicle does not provide any kind of data.
Okay, Florian, I think you have to start over on this slide. Florian, can you start over from the beginning of this slide?
Yes, okay. Is it better now?
Thank you. Yeah.
Okay,
you're back
hopefully
again.
You can hear me again. Okay, so just wanna just mentioned that as I said before, extended vehicle does not provide any form of data model, but on the other side, the working group, the project team has recognized the need as well for any form of structuring the data, not defining a specific data set, but creating some form of description. So therefore, about a year ago, informal subgroup data and functions description was established. And as Philippe mentioned at the very beginning, you got in contact with them now, and they follow the same motivation, investigating the development and or integration of a common data model or description or dictionary. So this is actually the entire point I want to make today. We could need some input, or happy to hear about input from your side, since you are seasoned and let's say experienced in these topics. And yeah, lastly, I want to mention within ISO, after that year, our scope is not fully clarified within the subgroup.
We lost you for a while again, Florian.
Ontology as
Florian, I'm sorry, we lost you again. We lost you again when you started talking about that the scope is not clarified.
Okay, so scope is not clarified. There are first drafts available. I'm not going to read them. Please take the time to read them on your own. But personally, I have the feeling the description sounds more like ISO wants to build up an ontology or use an ontology to describe their services and not build up a specific data list. So this is why I think we definitely should get in touch with the idea of integrating VSS, because VSS ideally covers both. First, a model, speaking as a rule set for vehicle data definition, and also a standard catalog. So I have the feeling that there should be opportunity for working group 6 of ISO to find an agreement with GENIVI experts how to integrate potentially VSS. Yep. So, and this is our very last slide. So here, I mean, I'm not, let's say, super experienced in these data models, but see it as a quick thought or food for thought from my side to start the discussion. I mean, you all understand much more about integration of VSS than I do, but with a layman's view, I would think it might be even enough for a start to map or tag VSS references in like your own data description within the JSON file, for example. And yeah, with that, probably I wanna end here and to open discussion. If we have a little bit more time, maybe throw the question into the round. What do you think is potentially necessary to start with integration of VSS into a communication interface? So what is necessary to make use of it? Either it be ISO extended vehicle or anything similar.
Yeah, I have a many remark. Philippe Favreau from Renault Group. I'm involved in working group 6 and also in the subgroup as Florian explained to think or to propose a scope for a standard for the data description. And of course, we have on our to-do list to contact or to gather information regarding CVII, of course, on VSS. But I have, I would like to make a precision or additional comment regarding in the slide number 3, Florian, regarding the scope of XV. If you can, yes. The extended vehicle is not only a web service interface. In the extended vehicle, you have 4 families of interface. Of course, you have web service for distant access, but you have also OBD interface for diagnostic, repair and maintenance purpose. You have also a time-critical interface, or essentially for safety-critical use cases in relation with a CITS communication, for example. And the last families, it's all-over interface, including in-vehicle interface. is for that. My remark is XV is not only a web service interface. For that, it's very important to share with working group 6 convener to exchange view and to explain what is exactly extended vehicle. To summarize, like extended vehicle is road vehicles plus mean of communication to the outside world in vehicle and off board, and a set of rules on basic principles to guarantee cybersecurity, road safety for occupants, to guarantee type approval conformance, to guarantee privacy, for example. It's my first remark. In the slide 7 also, I have another remark. Don't remember exactly the sentence.
Let's see if we can get to slide 7. We're a little bit behind in the agenda, so let's see if we can clear this up quickly.
Yes, strong Japan. Bidirectional communication is possible even with a web service. We have made the demonstration several times, but the last demonstration was under the PFA umbrella. It is a French automotive industry platform, like a VDA in Germany, for example. We have made a use case with exchange possible, with interaction with the driver through HMI of the vehicle. And another remark is for real-time access. You should precise what do you mean by real-time. It's a millisecond, microsecond, nanosecond. Of course, with a web service, we are dependent of the end-to-end communication, including cellular network. But you have, as I said previously, you have an interface for time-critical application with a time constraint, for example. And I don't understand the last in the last sentence. Theoretically supporting a non-disc. Why theoretically? We have no choice. It exists many laws and many regulations regarding non-discrimination, regarding a front, fair, non-discriminatory, and so on. I don't understand the theoretically. It means a car manufacturer always try
to specification itself is not enough to guarantee that. You need also those laws and legislation, as you mentioned.
Yes, and, of course, the implementation is important. Yes.
And OEMs need to be cooperative and not try to find the ways around that and so on. But
and for the
clarification, group, I think taken.
We have a meeting end of August, beginning of September normally. Maybe it will be very valuable for us to have a presentation of what is CVII or what is VSS for the ISO group. I think it will be very valuable. Yes.
Thanks, Philippe. So just to wrap this up,
Philippe, do you want to comment, Philippe? And the same thing to present clearly what is XV here. Yes.
Gunnar, please let me.
Yeah, Philippe, please quickly brief everyone on what's going on.
Thanks, Philippe, for your comment, and I think we agreed with Jean-François Ware about during at your next meeting. In addition, I would like to you whether organizing a presentation to the French PFA, which is the equivalent to the German PA, would help. Okay, and we can take this offline if you want. Okay.
Yes, I will provide you a link to a PFA website where you can find the French position regarding the use of data of extended vehicle. It's a very new French position.
Okay, but in addition, I would love to have a contact there. Whether I can go through you, and in order to get closer contact with PFA.
Yes, because we have the same approach at PFA level. We have also we have a small group to discuss how to characterize the data and so on. Yes.
Okay, good. So I will send you a note, Philippe.
Okay.
Thank you. On your email address. Okay, thank you again.
But maybe you could add XV, AutoSAR, maybe PFA position, maybe, if you want.
I'm sure you will. The two Philippes will sort this out.
Yeah.
And thanks so much for your clarifications, Philippe. We have now, we're a bit behind on the agenda. I pushed the break now here 10 minutes just to clarify that we will meet back 10 minutes from now at 5 to 6 Central European time. You will figure out what that is in your local time zone. 10 minutes from now, we'll come back and start discussing the AutoSAR connection and take this time to take a break. I hope to see you back here in 10 minutes. Okay, it's 5 to 6. I know I said 10 minutes. It was probably closer to 6 minutes, but we'll give it a few minutes to make sure people have time to come back. And then we should be ready to get started again. And Piotr, I believe you are ready.
At least I'm here.
At least you are here in person and in spirit. Well, we will. It's a collaborative workshop, so we will get through this together. Very happy that you will
okay,
lead
so
us through a few slides on this topic, and I'm sure there will be lots of questions and discussions. So we have we're short on time, so we should cover it fairly quickly. We have this topic to cover. I expect some questions. AOS with Artem, plenty of information there. I'm sure Artem will have to condense it in order to make the timing. And again, super interesting, and I would expect people have questions. And then hopefully, if we have time, I want to go through just a little bit of wrap up and discussion about how this all fits together. So without further ado, let's get started on the AUTOSAR connection.
Okay, so let me make an attempt to share appropriate screen.
Yep.
I hope.
In the meantime, I should take the opportunity to thank Florian for your presentation before the break. Don't think it was a major issue with the audio dropouts. We managed to get through it. So thank you, Florian.
Yep. Welcome, okay. And sorry once again. Go ahead.
Okay, I hope that I'm sharing the right screen. Should you confirm that?
Yes, we can see the slides.
Oh, so a bit of luck. So regarding this mapping of AUTOSAR, those slides are kind of reminder from last all members meeting. So to be on the same perspective, we are talking about adaptive AUTOSAR that uses RxML that are defined actually by this RCOM layer, I guess. That should be protocol agnostic, but it seems that in most cases this is some IP. And this is also most interesting case for us as there is this vSAM IP implementation that is open. And the current solution that could work actually for the VSS, and as was already mentioned, is this Farrakhan solution that consists of Franca, common API, vSAM IP, and a tool chain that can generate or appropriate definitions, and those generations is able to run together with AUTOSAR artifacts defined by this RxML and all adaptive stuff, and this is proved to be working by POC that was already mentioned. And it seems that for this moment this is something that is working and is one of the solution. So yeah, if you would like to see how it is working, what it is all about, there's here is a link. Here is a description. I don't think that we need to focus here how it is done. The most work, I guess, that was put in this project was actual mapping, and yeah, the mapping is a bit problematic in our case because both descriptions of the services are relying on just some data types, methods, and so and so. But related to VSS, there is a lack of information about, let's say, the role or the meaning of the data. This is the reason why we are talking about data model. And at some point, what we were trying to, yeah, you have here the idea that VSS now have some conversion to Franca. So you can choose a set of nodes, I guess, or values generated Franca definitions, and then using the Farrakhan toolchain or solution, you can communicate with our XML defined services, which would be the part of AutoSAR. But again, the problem is that the RXML and the Franca doesn't exchange the model. They just exchange some data, but we don't know what kind of data. What we were thinking of that we would like to do is to create this kind of a connection to exercise the Farrakhan tool and to provide it to some wider framework like Cook-Saval in order to check what actually will happen, what the problem will find. The first problem is that VSS mapping, in this case, are actually platform dependent. Yeah, there's no general definition of what AutoSAR should provide you, what kind of data. There is no straight data model defined. So as long as you know the platform specification, here we can use, for example, the demonstrator from AutoSAR community. If you are, of course, members, you can also use it to get the definition of the service and to try to do this VSS mapping. But again, this is a manual work. You can also do this with classic AutoSAR by using the signal to service. But again, there is no data model on AutoSAR side. The mapping needs to be somehow put to the AutoSAR feeder and is platform specific. And yeah, we were putting some thoughts how to deal with it. Maybe one of the approach would be to keep the mapping rules for the whole system in kind of a database and have kind of a gateway to the whole AutoSAR ecosystem. So instead of connecting to particular services, let's maintain the mapping set that will be platform specific. This could be, well, one of the approach. But yeah, again, the drawback is that the mapping needs to be adapted from platform to platform. This is nothing interesting. Nobody, I guess, would like to do it. On the other hand, there is somewhere a platform specification that those RXML were generated from, and I guess that the OEMs or the system integrators could have this kind of documentation, and appropriate mapping could be generated from there. But again, there is no standardization among those documentations. So each case needs to be adapted separately. This is also nothing that we would like to have. So the limitation of this proxy skeleton model that Aracom is doing is that we don't have possibility to have service discovery out of the box. We don't know what actually is hidden within the AutoSAR ecosystem, and we cannot automatically catalog it or parse it or do whatever during runtime to connect to it. We need to have this static specification. This is nothing fancy, nothing I guess that we would like to, and yeah. The question is, can we somehow avoid this? And maybe this is just another idea, kind of a service registration mechanism could be of use here, or maybe the Aracom changes can be introduced. Problem with this RCOM changes is that we cannot just change the RCOM and adopt the application as the applications are coming from commercial sources and cannot be just adopted. And the same with the specification. We cannot just change the specification at an outset. This needs to be done through all the AUTOSAR bureaucracy, let's say, and need to be accepted by all. So I guess that this option is not. So just an idea. Maybe we can create this kind of a component that will live outside of the adaptive API, and maybe if we are allowed to create adaptive applications, which means that you have to be, I guess, AUTOSAR member or the connected to the OEMs that has access to the AUTOSAR. Maybe this adaptive application can register to some kind of a central registration service and inform this component that I'm a service. I'm serving the values taken from the VSS trees like this, and then this kind of a mapping then can be stored and used in query back from rest of the world on regular, let's say, FARACOM basis, so that it can be mapped to those values from RxML. Appropriate service can be then located and queried. So that would be the ideas that we currently had. We somehow know that AUTOSAR is also interested in having some interfaces to and have some, and that AUTOSAR has some interest in VSS, but to what extent they would like to use it and how, this is for this moment not known to me. I just am aware that there is some interest. During some of our meetings, there was some idea, some comment that is there a chance that AUTOSAR will try to use VSS in communication between their components? And I guess that the answer for this is rather no. I don't believe that AUTOSAR will go into this direction. So I guess that the remaining options is some kind of a gateway or some kind of an access point that will allow to map the VSS to the services within AUTOSAR ecosystem. So that would be all from my ideas.
Yeah, thanks, Piotr. Okay, let's kick off a little bit of discussion on this. Are there any immediate questions or comments on the material or in this topic? Could be just a clarification or an opinion.
Or maybe another ideas. I guess that many sort of companies were thinking already about this, and I hope that maybe someone will be able to say that this kind of approach, for example, with this registration service is not worth the effort, or maybe it's worth of some investment. If you can share some thoughts about it.
Yeah, so we often get questions about this, how things should fit together. There's a lot of interest, but there's not always open discussion about it. It could be a lack of knowledge. It could be that people are divided up into some working on AUTOSAR topics and some working on the sort of non-AUTOSAR world. I don't know. in terms of what data will be used, I guess I think there are many ways to look at that. Either you have, someone wanted to jump in?
Yeah. Hello, this is Matthias Danseisen from Robert Bosch. I have a question to this slide beforehand. So I saw the proposal on in the AUTOSAR gremium, and so I was wondering on the interface if this is so the interface, let's say, out of the AUTOSAR world, which you have shown in the last slide. Yeah, this one. Yeah, here. So between the green box and the register. So this is where you want to specify in outer. So actually in the AUTOSAR gremium, this is where you would like to specify the interface, right? This is the vehicle API concept.
No.
Or where do you see that? Yeah.
This is a kind of an idea that is not completely related to AUTOSAR, and actually tries to not involve AUTOSAR as much as possible. The idea behind is here is that whoever will be developing adaptive application can to some extent make more than just AUTOSAR. AUTOSAR is requesting, and something that is out of scope completely of AUTOSAR, which is to communicate to some external registration service and tell to this registration service that this service that I'm representing, the service number 123458, will serve the data related to the vehicle speed.speed, and any query from the rest of the world could use this service. And then we can use a Farrakhan's tool to then communicate with this particular service from automotive world, from AUTOSAR world, and get the data and provide it to the rest of the world. So this is not related to what AUTOSAR is discussing. This is current idea, current solution, how to actually try to communicate with AUTOSAR world without having this preset of mapping, this hard-coded mapping that will translate the VSS model and this vehicle speed.speed to actual service and the values offered by this service.
Okay. So, and where would the concept then fit in? And if it wouldn't be on this register arrow?
This is something that is just a rough idea. Yeah. So this everything that is blue here is out of AUTOSAR specification. And this is just this could be a part of the CVII guideline or CVII solution, but the developers of adaptive applications then need to follow this kind of guideline or definition of interface to the registration service.
So one idea would be that this register blue arrow from left to right would be defined in an ARACOM, basically, as an.
This would be another approach, as I mentioned here. So yeah, the changes could be done on the communication level of AUTOSAR, but this needs changes in AUTOSAR documentation. And from current perspective, I was looking for some kind of a solution that won't be dependent on AUTOSAR itself, on the documentation, the changes, because I guess that any changes on ARACOM will inflict a lot of problems, a lot of changes down the chain.
At least it will take time to make such changes,
yes.
And there needs to be agreement on the value from all sides. But I think the key point here is that in terms of solving the integration issues that we have on the entire system scope, and when I speak about entire system scope, it's in vehicle that could be AUTOSAR or non-AUTOSAR based systems. You will have some vehicles that are built by non-AUTOSAR members. They will have no AUTOSAR technology. there will be some that have a combination, and there will be some that maybe are mostly or completely based on AUTOSAR. But I think we need to address the integration challenges and making it flexible in general. So that means working with AUTOSAR to talk about how can we create good things that are become part of that standard and make things really work. And it also means to work, as you mentioned, sort of looking at it from outside and say, what if you were to connect to an AUTOSAR system just as some external party or with a non-AUTOSAR platform? What would you have to develop then from independently in order to make that work? And we need to progress both of these directions because of lead times and things like that you mentioned, Piotr, that it may take time to change AUTOSAR concepts and specifications, and maybe it's not always necessary in order to create the connection technology that we're speaking about. So that's my view on that, and the same goes in some sense for the standardization of data and services. So far, it's also my understanding that the AUTOSAR organization is primarily interested in making the base technology platform and not on the functionality that is running on that platform. So when we speak about standard service catalogs and standard behavior, that goes on top of the technical platform as a kind of standard API, or if you want to really push it all the way, you could say that an entire ECU is well defined and specified from behavior and interface perspective. That would be called usually something like a commodity ECU. That concept has often come up, and all of that may be out of scope for AUTOSAR, but it's still something that may be of interest for the industry to create, and that means that you simply create a catalog of services that may execute on an AUTOSAR platform with all of those technologies, but the definition of that catalog lies out of scope of the AUTOSAR organization itself. And so there are various ways to address all of these things. In the end, you have to transfer data, you have to have services, so they will either be standardized or they will be simply agreed in the industry that this is not a common specification. It's just something that each system solves on its own when it's doing all the integration. Where we end up depends a lot on the companies that are involved there to see. But we're working on both of these ideas, talking to AUTOSAR to see how can we make things, the diversity of systems fit together better, as well as working sort of independently, because in CVII we're talking about supporting the integration of the diversity of systems, which means we need to take into account those that may not be AUTOSAR member or AUTOSAR based, and also speak about how do you look at it from the outside and integrate towards it as a kind of black box or whatever you like to however you like to see that. So I hope that clarifies a little bit where this is coming from, and this is just exploring ideas so far. I think Piotr doesn't have all the answers, and that's not expected today.
No
with
answers,
that said,
just questions.
Yeah, exactly, and that's good. That's what we want to have here. We want to get the conversation going, primarily about what all of you need in the companies out there. What are the sticking points and the challenges that you have in putting together the complete system, the working vehicles, and the vehicle to cloud systems? So it requires input, and this is not the place to give all the answers today, but only to say that this is a topic we're working with and attacking from different angles. with some ideas already up and running.
But the main message is that yes, there is a possibility to get data from AUTOSAR ecosystem. We know that Farrakhan is able to do it. At least from my perspective now, the main challenge is to find the appropriate place or the way how to maintain these mapping rules. Either it will be like here, so that you have access to the platform specification, platform documentation, so you can create, generate, maintain whatever the actual mapping, so that you know the service IDs from AUTOSAR, you know how to translate them to a VSS branch, or you have access to the adaptive application itself, and you can change this application in a way that besides acting as an AUTOSAR application, it is also able to tell the external service that I am application of I am service that is called blah blah blah, and I am responsible for example, the speed measurement. In this approach, you don't need to have the full platform specification. This is kind of a service discovery mode, but you need to have access to the adaptive application developers.
Yeah, and we have to wrap this up, but just to tie back to what Magnus talked about before, the Farrakhan tool is we've proven that to work. I think if companies want to use that as the sort of the production approach and really using that fully, then you have to realize that there's some maintenance effort probably keeping that up to date. AUTOSAR specifications may change slightly and over time, and it's like all tools, it needs to be kept up to date. But there are other opportunities, as Magnus mentioned, directly generating some IP mappings of various sorts from the common description of data and services. So I think we don't need to look only at the existing tools today, but at the opportunities of creating those mappings. We do need to move on in the agenda, so I'm glad we opened up this topic a little bit, talked about the fact that the working groups are thinking about it, and hopefully get some of you to join that discussion and help bring the conversation a little bit further forward.
So thank you. That would be all.
Thanks so much, Piotr. And we've been short on time the whole day because of some technical issues. So let's make sure we jump over and hear from Artem. It's a really, I think, a really interesting system that you want to look at, that is related to the work we're doing through the use of standard data descriptions and so on. And I will speak more about how we intend to hopefully use this even more to build systems together. I will make some references to that after we hear about what AOS is today and what the plans are. So go ahead, Artem. Thanks for doing this presentation.
Everyone. Please let me know if you see my screen. I'm not sure if everything works for me as well.
It looks good, yeah.
Okay, good. Thank you. So I'll explain the system that we are creating together with Renaissance Electronics and offering to mostly to automotive market, to OEMs and Tier 1s, but to other market verticals as well. We already have deployments in addition to automotive. That's also healthcare, medical, and consumer electronics and oil and energy. The main idea of the system is actually to create a way to access on-device in automotive, that's on-vehicle data, although the system itself is not data-centric. When we started working on this, traditional approach utilized by many OEMs and Tier 1s was to, well, it's not only relevant to automotive again. is to get all of the data from the vehicle or any smart unit into the cloud, into the data lake, do the processing, and provide access to the data to customers via some subscription or whatsoever. That approach works well, although it has some drawbacks. Among them is, well, with the amount of sensors and amount of data generated by vehicles and other devices, even with 5G, network traffic becomes an issue. Vehicles are moving around and connectivity is not always granted, so flying reactions on a data change is not always possible. Well, not possible at all. And OEMs, unfortunately, OEMs for vehicles, for equipment, have different ways to represent our data, and that's probably what GENIVI is about, is a way to standardize, but we are not there yet, unfortunately, and there is no standard data representation, and even there are some competing standards to do that, competing approaches. So instead, we decided that we will push edge services not to the telco edge, but rather to the vehicle itself in a containerized form. Well, it's pretty straightforward, right? So that edge service will have a direct access to the vehicle data. Again, that's where standardization is required. And only control flow remains, like what to deploy, how to deploy, when to deploy, and edge service can talk directly to its own cloud, of course, in a regulated way with the reduced data flow. By reduced, I mean it's not going to just upload everything, but probably is going to pre-process or transfer data and so on. Oh, sorry, perform the data transformation. So that also gives another view. Previously, the representation of data, like I took vehicle signal specification as an example, but it can be any kind of OEM's representation, right? The transformation happens on the cloud and processing happens on the cloud into some, and if there are like some third-party services, then enterprise data representation happens also on the cloud. In this case, the representation can be changed right in the vehicle so that with the minimal computing power requirements, so that the data flow between the vehicle and the cloud minimized, or if the offline reactions are needed, they also can happen right in the vehicle without the need of involvement of data flow, and it can be only reported when connectivity appears and so on. And the cloud remains its own enterprise data representation, not bound by any regulations of OEM or standard or whatsoever. So with that idea, we created a system to deploy containers to the device so that these containers can talk directly to their own clouds in a regulated way. It's similar to what is now growing at telcos as multi-access edge computing, but it's for vehicles with much higher level of restrictions. And initially, we were thinking of more constrained environment than a nice server in a 5G tower or 4G cell tower, and security is much more in focus. But all in all, there's a lot of things that probably you will find familiar. We decided not to invent the wheel, similar as Gunnar mentioned. We don't want to follow the XKCD standard pitfall. Instead, we took existing standards, like for containers, we took OCI specification. EPAM, we are Linux Foundation members and participating in multiple Linux Foundation activities. So it was easy for us to get through that. For data abstraction, like being from automotive, we took vehicle signal specification, vehicle interface specification. Again, that works for vehicles. For other industries, that may be different. But again, for automotive, that's something we believe the best way to access. And with that, we created this kind of system, and it's up and running already. It's in production state. And using it, we have found some gaps, maybe not immediately required by all of our customers, but definitely needed for future. Like, for example, I don't know if all of you are familiar familiar with OCI specification, Open Container Initiative. Basically, it was developed initially when Docker was introduced. I don't remember how many years ago, and then Docker, like all of the project specs, were contributed into the Open Container Initiative by the Linux Foundation. And right now, most of, if not all of the container solution vendors, including Podman and OpenShift and Red Hat and other stuff, are using basically container OCI spec for their containers with different extensions, with different ways to configure it. Like, for example, Docker has its own Docker file to configure, like for humans to configure, and then this will be somehow processed into OCI. So OCI is always used in these descriptions. But OCI itself also has gaps that I've just mentioned. Like, since it's been basically server-side or cloud-side centric, doesn't have a lot of definition for device access, doesn't have automated service discovery or service catalogs. Quota configs are very simplistic. Again, on the cloud, you will find only CPU and memory. Nobody cares about anything else. And API access rights is also something that is out of scope for OCI. So when we analyzed that, we decided to create an own description for containers deployment that would amend, not, let's say, redesign the OCI, but amend the OCI. So you will see, like in the middle, we have the initial YAML. It's like Docker file, right? Which is transferred into standard OCI manifest and image config. But there's also additional service config, which covers those gaps that I've mentioned. And gaps are examples like extended quotas on an embedded device. You really care about not only CPU and memory, but also storage consumption, intermediate state of the service for stateful services, network traffic, network speed, priority for the traffic itself. There's also extended security configurations like TTL for when device is not updated for a year. You may consider that is vulnerable, so you can have a TTL so that it will stop working or service will stop working. With restrict and bound connections, and there might be some, and allowing those inbound connections for very, very corner cases, and other things that are falling into category of secure configuration, and DNS configuration for automatic service discovery. So if there are like multiple these containerized services running on a device, I'm not talking about the functional safety services or native vehicles. It's more like edge services, right? If they're running, they need to somehow discover each other, and they are dynamically, the stack of these services can be dynamically changed, so they need to discover. And right now we implemented that via DNS, and that's probably not the best way to do that. I will talk about it later. In addition, direct access to devices with some virtualization protection like v4 whatsoever mounts and some system resources that are directly accessible from container, again, and protection mechanisms for those are described in this kind of YAML. And for API, by default, we created a subsection where we just took this VISS as is and used it, and we are pretty happy with that. And that's why we want to help like further development of the VISS and related standards. We have implemented all of that. The spec and the embedded side is under Apache 2 license, and right now we are planning to publish all of that with Renesas. So unfortunately, there's some legal obstacles we need to overcome. Legal guys are very slow in taking decisions, but then maybe you are familiar with that. So as soon as that got solved, all of the code is already under Apache 2 license. We just need to like say, yes, we are fine to deploy and to publish that. Hopefully that's going to happen soon enough. And that include the implementation and the spec, both the YAML spec and the extended config and so on. Extended config, we hope to get rid of it at some point and contribute everything to OCI, and we are now, as soon as that the publish approval get through, we will start contributing to OCI through Linux Foundation connections that we have. Yeah, a few words about in-vehicle data access and why we chose, why decided to go with GENIVI specifications. Well, each service has its own certificate, so everything has certificate, and we have a local VIS server which provide data access to authorized services, and transport must support MTLS, and that works perfectly with WebSockets. It can work with other interfaces. The more major requirement is that we have MTLS between every point on the vehicle, so everything has to be encrypted and authenticated. All of the vehicle data is responsible by represented by VSS. We can have extensions, and we actually had extensions. We support extended vehicle. We played with Volkswagen's VV, or for medical, we implemented their own APIs. But we always say that much better to stick to VSS. Well, at least for automotive domain, or maybe some industrial domains as well, which have similar things like heavy machinery, for example. We found out that things like huge trucks that are like mining trucks and excavators, all of them are very in love with VSS, although they are not really participating in GENIVI for some reason. I don't know why. So with that, each edge service may perform its own way of processing, pre-processing, or non-standard transformation for standardized services into whatever its own backend expects. And it can be written in any language. It can be Python, whatever. We don't limit, nothing. We only say that's the transport, that's the API, that's the service discovery methods. That's it. And a very transparent description, as I said, OCI-based description. And yes, servers can also send in a similar way, like first approach, send the vehicle data to a data lake, all of the data, or if when needed, like based on events or whatever. So basically, that's very flexible, and all of the based in VSS. And we try to separate where the data representation is standard, or let's say give a flexibility on separation where data representation is standardized and where it's proprietary, enterprise-driven, or custom. Other gaps that we have found but not yet solved, we have already had cases when there's a third-party service provider that deploys edge services for vehicles of two OEMs, and user potentially, that's not the real case yet, but user may migrate from one vehicle of one OEM to another vehicle of a second OEM, and second OEM may have a different authorization type, like first OEM may have a key and second have like biometrics, but somehow they need to get to a single unique user ID, and second may request from the first one or from a group of OEMs the enabled service stacks to enable it on the vehicle, and then it may have its own filters and blacklists and everything. But the main, well, there are technologies exist for server-side world like OAuth and OpenID and many others to implement that, but we have not yet made up our mind, and we're really looking forward this kind of things to be standardized. And same for, as I already mentioned, service catalogs and service IDs as well. Like if OEMs have have a service from the same third-party service provider, and it needs to migrate from one vehicle to another, how can it do so? And how to build a chain of trust, and how to authorize, and all of these questions that we don't yet have clear answer. And we have tried to go through industry, and that's also not the case yet. So that's the other thing that we are really looking for to find and maybe to develop with VISS. Oh, sorry, with CVII, and not concentrating on the data only, but concentrating also on entities like edge services and users that are generating or processing this data. That's very briefly all. Yeah, and I really love to hear some maybe advices or discussion on what's possible of this kind of shared authorization, and if it's at all on the plate for other GENIVI members, or if it of any interest for other GENIVI members. Hopefully I'm not disconnected, I don't know.
No, you're not. Yeah, any questions to Artem or comments on all of this?
Thank you, Sebastian.
So I think you should be able to just unmute and ask if you have some questions.
Hi, this is Jeff Dever. So services from different OEMs shall be uniquely identified to allow inter-vehicle user settings migration.
Mm-hmm.
So are we talking about, well, I can sit in my GM vehicle, have a set of settings for the seat, and then jump into my Ford truck and have the same settings for the seat?
Yeah, it can be settings, but settings are you're right, but it's like very simple, although important example. We also think of, like, for example, you have a UBI provider. I'm just from the top of my head, right? And you have like your insurance provider, UBI provider on your vehicle, and then you're jumping to another one, and the service that actually processes the vehicle data, collects everything in the head unit, also gets deployed to the second vehicle with the same settings and everything. So it's not only the configuration data, but also some processing logic as well. So it's beyond the data. Does it make sense to you?
Yeah, I think it's a cool goal, a cool objective.
Yeah, so within a single OEM, we already can reach that. But the system that we produce, we don't deploy, we deploy it on OEM's premises. But when we think, like, what happens when you have two OEMs? What happens when, and OEMs won't be able to write all of the possible, like, services in the world, right? The whole idea of connected vehicle and opening up the data is to monetize on other services, somehow processing and using this data for their own business models and everything. So it's not just selling the data, but also selling the capability to process data. And with that, if you have third parties start using this approach, or maybe not ours, but similar approach, any kind of edge computing approach, how do they migrate between? So if I, how do they migrate between ecosystems? If that's going to, is it going to be like full fence, like, Apple in mobile world, Apple and Google, their own services do not migrate, but third parties, when I'm installing, logging in, all of the data and everything migrates. That's funny, but not the data. The processing logic itself is something that can migrate. That's what we are really looking forward to. Maybe if somebody's interested to discuss or to throw some ideas on the table. Maybe I haven't looked myself into what XV standards suggest, but I've seen there's a OAuth OpenID for cloud authentication. I don't know if you can reuse that for wider cases for edge device or cross-boundary authentication. That's not clear to me yet.
Yeah, maybe. Thank you for the answer.
Thanks.
That's a classic question, this one. I fully agree. It would be really interesting to start an initiative to talk about solving that. I mean, the identification of the actual user from these whatever tokens or whatever abstract representation you have of the user tied to the actual user.
Yeah.
That's a first step, right? And then comes a really forward-looking, interesting thing about these services being able to migrate.
Yeah, yeah. In general computing world, there are already ways to authorize users and other entities in distributed systems when there's no centralized entity exists that owns everything. And I bet OEMs will not allow another OEM to own everything, right? And authorizing without exchanging sensitive user data today is also super important. And again, in general computing, that also exists. And I'm just looking for approaches or maybe researches that somebody already did that we could propose maybe as a standard, offer as a standard, or offer as a generalized approach and discuss. Yeah. Anyways, I hope that is something you find useful. Maybe it's not addressing immediate need for everybody, but we believe that this is something that will arise at some point, and I'll be happy to work on that within the CVII group if we see there's a value and somebody else is also interested in that.
Very much so. So Florian, again, really great questions you've been raising. So definitely would be interested to find answers as well.
It certainly is a common interface question for vehicles, and while it's not, it would be I think a new topic for us, but very interesting one.
Yeah, I don't really want to, to bloat the CVII group with something that nobody is interested in. I'm really looking for if there is an interest, and if there are some few companies who can spend some small amount of time to do the research together, maybe suggest something. So yeah, that's all. I'll be happy to follow up.
All I'm saying is I'm happy to support you and help you with that. So I don't think it's blowing up anything really, but it would be just an extension. But you're right. I mean, it comes down to the companies being involved. It always does.
Yeah. Thank you all for listening.
Thank you, Artem. So we have about 10 minutes left or so. Thought I'd just give a little bit of a wrap up, and very happy that you stay with us for the whole time, those of you who are here. So I already mentioned what we mean by technology stack. It's one of the tracks in addition to the track of aligning consensus around the data model and services model. And this is about the development itself. And so with all of these different tracks, we have the technology stack on the right-hand side and a number of ongoing projects that are tied to it, and the main scoping and planning project where we have the high-level discussion, and that can then have breakouts towards these different topics. That's the general overview. We've spoken about this before. The type of programs that we might develop range from the tooling side, format converters, code generators, to the definition of protocols, to the implementations of libraries and bindings, as well as storage and analysis potentially in the cloud. I mean, it potentially covers all of this because, in a sense, once you have decided on for example, a data standard, then that applies in all of these areas, which doesn't mean that this group needs to define all the details on each of these topics, but definitely will touch upon all of these topics in some way. And the way I look at it, and I'm presenting this for the first time for feedback and just to open up our thinking about how we may do this more practically. I mean, we're on our way already. We're running fast in certain projects, but on the higher level, we need to sort of get together on a common plan, get everyone who wants to be involved actively involved, and so that's what I'm talking about here, taking a higher level view. So one idea, of course, is that I think we need to agree on a kind of high level architecture about what is the scope of the projects we're dealing with. It could be very simplified, something like this: the in-vehicle stuff, the vehicle communicating with sort of edge-related or specific road and city infrastructure, as well as communicating with other vehicles. There's the connection to the cloud, which often follows the extended vehicle approach, as being OEM having sort of their initial connection to their vehicles and then distributing data to a neutral server to which the third-party service providers, web apps, and various developers connect to. Now, in reality, you have a couple of more errors. I mean, you have direct connections between the vehicle and third party sometimes. If you don't believe me, just consider how every single Android application works on your phone. Every app speaks to their own backend without the intervention of Google or anyone else. And for vehicles that accept normal standard Android applications, this is of course the case for every such application as well, that they speak to their own service provider backend. And so those additional errors of course exist. But as a simplified, we need to agree on some kind of high level architecture, and this is just an example. There's development environment and all of the tooling around that also is part of the technology stack, so that we also need to work on. So I proposed here, just for the discussion, that we say that software can be divided into software components, just to have a simple terminology to use. Now, how do you define software components? We could define them through implementation or specification. You may say, what about both? But I'm here kind of just making a distinction that typically open source implementations, for example, a lot of times they develop the code and the behavior at the same time. They figure out as they are writing code how it should be working, rather than, of course, I mean, there may be specification, but there is very rarely a complete upfront specification that is completed before you start coding. That's just not how those projects work. And so that would be an example of specifying a component through implementation, is by focusing on that implementation project. Another way is to focusing primarily on the specification first, and only then, of course, implementations will end up. But as far as this group is concerned, the focus would then be on specification. And then we can see some variations on that. I don't know why this is indented here, but it seems to be some reason. Okay. I would say variations here is you start by finding and selecting and agreeing on existing components that you can find out there. A lot of times those, of course, are open source components. Doesn't necessarily have to be 100%. But when it comes to sort of finding what already exists, a lot of times you would look into what open source implementations are there. And you can find the variations here. So existing open source software, it could be existing specifications, or it could potentially be the third, existing sort of commercial / non-open source implementations. And I'm not making the distinction there. Obviously, there are commercial open source activities, but I think you understand the point. So in the case of 1C, when we do collaborative projects like this, we really would have to see that there is a market which provides multiple possible implementations, because it's rarely a good idea to have a monopoly on a particular part of the technology stack. It's not good for the industry overall, if we put it that way. There needs to be choice and a healthy competition is a better situation. So that would be the need if it's not licensed in a way that that everyone already can use it without restrictions, such as open source licensing provides. Number two would be filling gaps where we see that we don't have the necessary component. We could do that by starting a new open source development project together, or we could fill the gap by starting a new specification project together. I hope I haven't left out some variations. Happy to see if you to have your input if you see some holes here. General principle then, we have to create an environment with flexibility and choice to a certain degree, and that comes back to the discussion we've had a few times today, which is find that balance between choice and flexibility versus kind of fighting a little bit against the very large fragmentation issues we have in the industry and the challenges we have because of that. Whatever we do select as a group and say this is kind of our favorite and we have some kind of rough consensus, it should be the best or at least among the best technologies, good enough and certainly among the best. As I said, agree on preferred choices, reduce fragmentation. And while doing that, we need to have a continuous discussion together because companies have needs, companies have legacy technologies and constraints in terms of selecting these technologies and figuring out, and of course previous investments into technologies. We don't want to fall into the sunk cost fallacy, of course, but investments that are made are often important to consider. Then as a complement to the definition of those components, it's likely that as a group we want to make integrations of parts of the stack together. And I say parts of the stack because you may need to, I'm just gonna see what happened with the edits there. We may need to not do the entire system at once, but to do certain parts of it, proving that it works together, working out the integration issues and so on. And so there will be a balance of creating these software component projects and some integrations. Once you have the high level, you would sort of break it down into components and talk about developing those according to what I said and the methodology that I just talked about. And in the end, then we looked at this slide already. This is the one I want. Step 3 then would be sort of selecting which components do we start with, right? How would you do that? So you define this full stack architecture picture together. You define the desired features and functions and requirements, and then you search for existing solutions. This is one approach that we could take. It's maybe the most standard approach. I think it's difficult to keep the pace if you get stuck on number 2. In a collaborative project, getting everyone to sort of agree on the features and functions and requirements up front, that has to be fairly lightweight. And it cannot be an approach to try to make it fully complete. I know some projects work that way, but they also work very slowly over a long time. And in the meantime, the industry may want to progress faster. And if we don't keep pace, then the collaboration breaks down. So this is one approach, and I can't think we can do it with a lightweight approach. But in a parallel with this, I have this idea that we should look at the existing projects that have come far. We just heard from AOS. We have worked on the CCS project in GENIVI for quite a while to define a reference architecture and implement that in order to prove it. There's the implementation from Bosch, which I might not be a comparable full system, but it does provide a a subsystem functionality and certain components included in that. And I think there are other projects out there in the industry that we need to start connecting to and say, you know, you're welcome to continue whatever you're doing, but please consider at least attaching to the standard data model and principles so that we create compatible technology in the end. Now, if you imagine you take these kind of architecture pictures that you have and you sort of place them on top of each other visually, we would be able to sort of see which are the common components here in these approaches, which are the places where you have the same feature, but the companies or the developers have chosen different solutions because they've gone ahead and done the implementation in a different way. And then we can talk about, is it one way preferred over another? Is there a way to figure out where we should have the diversity and where we should have the commonality? And ultimately, by looking at these things on top of each other, identify which parts companies want to develop and if there are any parts that companies want to sort of do on their own. And we got the clarification now from Artem that AOS intends to provide the entire, or most, I think the entire implementation, if I understood you correctly, Artem. At least significant parts. And so, but that differs between different approaches, and you can sort of overlay these and figure out which parts, where do we have the overlap for collaboration, either through existing projects that we can get behind and improve and maintain together, or where we find the gaps, new components that need to be developed. So I think we should follow these two approaches at the same time in some sense, talking about, you know, what's the ideal full stack architecture if it's possible to make a single picture out of that, talk about the requirements and what we need, but at the same time also compare and overlay these components from existing projects. And I know we're out of time, so I will wrap this up quickly. The key point on this slide is really to go through the process I talked about, working on clarifying what's available, first of all, where are the gaps, and in order to really make this possibility, I think we need to support, first of all, the ability to build systems, whether they are done by individual companies or a group or another group. We need to simplify the ability to build that first before we can start working towards alignment. And because alignment doesn't mean anything if it's not being developed. And I think a key point there is that we take the software components and fully understand them, how they can be reused in a different constellation. So how do we make them reusable for someone, whether it's ourselves in a group or some other company or some other constellation, to make them easy to reuse to build complete systems. And that means we need to do some analysis on all of those components. And we've started that with the Bosch Analytics and Vehicle Edge with a particular page that is linked here. I won't click into that now because of the time. But I hope that gives us a bit of an overview. And that was all for today in terms of the approach that we would like to, that I would like to propose for this technology stack development. Okay, we are over time, and I want to thank everyone for joining. If you need any more information how to get started, you can always email me. You can go to the projects.genivi.org wiki and just search for Common Vehicle Interface Initiative. It looks like my network is down or something, but the homepage should be there.
And you can join the CVII Tech Stack call on Wednesday.
Yes, all of the information about these calls are in the homepage.
Yeah, which is a good entry point.
So I seem to have lost perfect timing. I've lost the internet on my sharing, and that's why the slides seem to be stuck as well on the sharing.
Oh,
okay.
Okay.
Well,
but we have the audio, and
yes, you heard me on a separate audio connection, which is good. Let's wrap up for today. Big thanks for everyone participating, and I hope you will join us in the more regular meetings because that's where the exciting things happen. If you have any questions or you want more updates, you just drop a line to any of us at GENIVI or W3C, and we'll go from there. Thanks, everyone.
Thank you. Good night.
Thank you.
Thanks.
Bye-bye.
Bye-bye.
Thanks, good.
Bye.
Appreciate it.